Something strange happened when companies started giving their engineers AI coding tools. Productivity went up, code output doubled. Some teams tripled their shipping velocity. The pitch worked exactly as advertised. Then the bugs started. Not small bugs, production bugs, silent failures in payment systems, race conditions that only appeared under load, database migrations that wiped live data because an AI agent couldn't tell the difference between a test environment and production. 72% of organizations are now facing production incidents directly caused by AI-generated code. That's not a prediction. That's the 2025 State of AI Software Engineering Report. 3 out of 4 engineering teams right now cleaned up messes that AI made. So here's the contradiction worth sitting with. We were told AI would make software engineering faster, cheaper, and easier. And it did. It absolutely did. But faster code generation plus weaker engineering judgment equals more failures, not fewer. The thing that was supposed to reduce incidents is causing more of them. And that gap between what AI can generate and what actually survives in production is where the most valuable engineering careers over the next decade are going to be built. Let me show you exactly what I mean. GitClear analyzed millions of lines of AI-assisted code and found something that should concern every engineering team: code churn. Code that gets written and then reverted or heavily modified within 2 weeks. Nearly doubled between 2021 and 2024. AI writes code fast, it just doesn't write code that lasts. VeraCode's 2024 security report found that 70% of applications contain security flaws, and the attack surface is growing as AI accelerates code volume without proportional review. More code, same number of humans checking it, the math on that just does not work. And here's the one thing that should stop you. Stack Overflow surveyed developers in 2024 and found that 76% are using or planning on using these AI tools, but only 43% trust the output. Think about that. More than half the engineers using AI tools don't actually trust what those tools produce. They're using it anyway, which means someone has to catch what slips through. Then there's the debugging problem. A study from METR, that's Model Evaluation and Threat Research, ran a controlled experiment with experienced developers, real engineers, real tasks, AI assistants available throughout. The result was that task completion time went up 19%. Developers who felt faster were actually slower when you measure objectively. The confidence AI creates is not matched by the reliability it delivers. Stripe surveyed their developers and found their engineers are spending 17.3 hours per week on technical debt and maintenance. That number is going up, not down, even as AI adoption accelerates. This is exactly what second-order thinking would predict. William Stanley Jevons figured this out in 1865 studying coal consumption. When you make something more efficient, total consumption increases, it doesn't decrease. AI makes code generation efficient. The result is more code, more complexity, more things to maintain. Every engineering leader who thought AI would shrink their maintenance burden is now managing a larger code base with the same team. Now, let me tell you about the Replit incident because this one is specific and it matters. An AI agent was tasked with a database migration, which is routine work. The agent queried a production database and got back an empty response, probably a timeout, a permission issue, something mundane. The agent's interpretation: this must be a test environment. Nobody would leave a production database empty, so it deleted the database. The agent did not understand the difference between production and staging beyond a variable name. It didn't have the instinct that causes every experienced engineer to pause before running a destructive command, to triple check the connection string, and to ask the colleague. That survival instinct, the one that makes your stomach drop when you're about to touch something that is processing real money for real people, AI doesn't have that. And this is not an edge case. This is what happens when you deploy systems that generate confident sounding outputs without genuine understanding of the consequences. The people who caught incidents like this before they escalated, the engineers who reviewed AI output with genuine skepticism, who trace failures across distributed systems, who understand why legacy code looks the way it does, those people are not becoming less valuable. They're becoming the most valuable people in the building. So why does this happen structurally? Why does AI keep failing in these specific ways? It comes down to a few things that are actually pretty fundamental. AI models are probabilistic pattern matchers. They don't reason from principles. When you ask an AI to design a distributed payment system, it suggests the most common pattern from its training data: microservices, standard architecture, textbook solution. What it cannot account for is a regulatory requirement that makes a standard pattern illegal in your jurisdiction, or a legacy mainframe dependency that makes the proposed latency targets physically unachievable. The CAP theorem is a good example: consistency, availability, partition, tolerance. You can only pick two. AI can define this theorem. It can give you textbook examples, It might tell you that an e-commerce site should prefer consistency to keep inventory counts accurate, but a human engineer knows that on a Black Friday, you might deliberately choose availability. You let customers add items to their cart, even if the inventory count is slightly lagged. The worst case is overselling a few items and issuing refunds. The alternative is showing an error message to millions of customers during the highest traffic hour of the year. That's not a technical decision. That's a business risk decision that happens to require technical knowledge to execute. AI sees architectural problems as having correct answers. They don't. They have compromises, and picking the right compromise requires understanding what failure actually costs. Then there's the legacy code problem. There's a principle called Chesterton's fence. You shouldn't remove a fence until you understand why it was built. Legacy code bases are full of strange conditions, redundant checks, code that looks like it shouldn't be there at all. AI sees inefficiency and recommends refactoring. What it doesn't see is that those conditionals were put there after a specific incident in 2019 that nobody documented anywhere except the Slack thread that no longer exists. IDC estimates that 1.52 trillion is spent annually on IT legacy modernization. A significant portion of those failures trace back to exactly this problem. Teams that removed the fence then discovered what it was keeping out. There are over 800 million lines of super old code running in the US federal government. That code processes 13 trillion in daily commerce from Social Security, the IRS, financial clearing, and there are fewer than 10,000 programmers under 40 that exist in this country. The engineers who understand the system, who carry the institutional memory of why things are the way they are not competing with AI. They have a moat that AI cannot cross. And then there's the accountability layer that most people aren't thinking about yet. The EU AI Act is explicit. AI cannot be held liable. Only humans can. If an engineer accepts AI-generated code without adequate review, and that code causes a data breach, the engineer and the company are liable for negligence. AI is classified as a tool. The human who used it without judgment bears the consequence. The GitHub Copilot copyright lawsuit highlighted another dimension. AI models trained on open source code may reproduce that code in outputs, creating IP contamination risk for anyone who ships it without review. The legal exposure is real, and it's landed on engineers and companies, not the AI vendors. McKinsey 2024 survey found that only 4% of companies are capturing significant value from AI at scale. The most common barrier wasn't technical, it's organizational. Unclear ownership, misaligned incentives, business needs that never got translated into anything a technical team could execute against. Harvard Business Review analyzed 344 AI projects and found that initiatives started by business stakeholders without engineering alignment failed at twice the rate of cross-functional experts. The 75% failure rate for AI initiatives isn't a technical problem, it's a translation problem, and humans are the only ones who can bridge it. Here's the reframe. The conversation about AI and engineering careers has been framed wrong. The question everyone's asking is, will AI replace software engineers, which is not the right question. The right question is, which kind of engineering work survives and which doesn't? Writing syntax is getting automated. That was always a means to an end. The actual work of engineering, designing the system under real constraints, diagnosing failures in distributed environments, understanding why legacy code exists before touching it, translating what a business actually means into something that can be built, standing in the room when production is down and the executives are panicking, none of that is in the training data. The engineers who are getting squeezed right now are the ones who define their value by lines of code produced. The ones who are gaining leverage are the ones who define their value by problems solved. AI writes faster. Engineers decide what to build, verify that it works, and take responsibility when it doesn't. The coder is being automated. The engineer is not. Those are two different jobs that have had a shared job title for 30 years, and AI is finally pulling them apart. For you mid-career professionals out there, this is a very significant opportunity if you move on it deliberately. Senior engineers with domain expertise in high-stake industries, banking, healthcare, insurance, federal systems, are commanding rates that junior AI-generated code cannot touch. DevSecOps and site reliability roles are seeing above average salary growth specifically because AI is generating more vulnerabilities faster. Technical product managers who can translate business requirements into executable engineering specs are earning 160 to 200K in major markets because that translation skill is exactly what the McKinsey data says most organizations are failing at. The gap between where you are and where these roles are is not as large as it looks. Many of these skills we've talked about today, systems thinking, debugging discipline, stakeholder alignment, business judgment, these are things that accumulate with experience. You likely already have more of that than you realize. What most people are missing is a strategy to make that value legible to the companies that would pay the most for it. The job market right now is very inefficient. Companies are paying junior rates for senior judgment because senior engineers haven't been taught to articulate the difference. That's a positioning problem, not a skills problem, and positioning problems are solvable. So if you're a mid-career engineer or product manager or salesperson or marketing person or finance person, even remotely related to tech, and you feel that sense in your stomach of, man, is now the time that I should make a move. I should take this seriously. I should be looking for a more secure role, potentially even working multiple remote jobs so I have income redundancy. We at Elevated Tech do done for you job search. So we apply to 2,000 jobs per month for our clients. We treat it like a math problem. If we can apply to 2,000 jobs per month, get a 1% reply rate, that's 20 interviews a month, and people are on their way to a new job. That's how we're able to offer a 90-day placement guarantee for many of our clients, and why over 600 professionals from Meta, Netflix, Airbnb, Google, ESPN, Accenture, and more have trusted us to run their job search. So if you want to see if you qualify for our Done For You job search program to make sure you get your next remote job in the next 90 days, click the link below, subscribe, and we'll see you in the next video.